Flint, my trusty sidekick over here, meteorologist extraordinaire.
It's extraordinaire. I don't know. Let's see. We're kind of. I got my mic on. Okay, we're good.
Yes, we're good to go.
You know, it's been a crazy couple of days here at the television station.
It has so much going on, and but we're still here to do Weather Academy. And again, shout out to all of those teachers who are having their students watch us here as part of their curriculum. We do appreciate and glad that you consider us worthy of actually teaching you real weather information.
Well, you're the teacher, man.
Well, no, we're trying.
You're teaching me to teach, is what's going on.
No, it's good stuff here. No, stop it. Nope.
But yeah, we do hope that you're taking something away from this and hoping, we hope that we're kind of helping you out with a little bit of science and meteorology. So let's see. What did we discuss last
well, let's see. We had clouds.
Clouds, that's what it was.
Different types of clouds, yes.
Different types of clouds. And we're going to kind of talk about clouds again because thunderstorms, which is our topic today, come from a cloud called the cumulonimbus cloud, which we briefly mentioned on Monday.
The godfather of clouds.
And this is kind of timely because I'm sure some of you might be kind of rubbing your eyes a little bit right now if you're with us live at 10:30 here. Because it was a little noisy last night. We had some of those thunderstorms move through last night.
Oh, big time,
Incredible lightning. We had some small hail and some wind associated with them as well.
We did, and some damage. Some damage down trees with wind gusts and 1-inch hail reported by some spots.
And it's always cool to see lightning at night. It's really cool.
It was
great.
And there was
light
a lot
show.
of it. There was a lot of it. Woke me up. A lot of a sound sleep.
On that note, before we dive too much into it, so I had a great question on Facebook Live last night, like, well, you know, this thunder sounds different at night, and it's actually true, because at night the air is a little more stable, it's quieter, okay? So those sound waves can propagate, I should say, through the air a little bit easier. So that's why you get that rolling thunder sound at night. Pretty cool stuff. But that's why thunder sounds a little bit different at night because of the stabilization of the air. All right, ready to talk some thunderstorms?
I think so. Okay, let's chat. What is a thunderstorm, Craig?
So they are most common. They can happen any time of the year, but they are most common May through September. You know, that's when you get the heat and the humidity, and that's what creates thunderstorms. Basically, it's a collision of warm and cold air in the atmosphere, and they don't like each other. They're enemies. And like we had last night, they can contain hail, heavy rain, frequent lightning, and damaging wind. So that's kind of that's the quick and dirty way of classifying what a thunderstorm is. Really, if you wanted the simplest explanation is it has to contain lightning.
Right.
That's what classifies a thunderstorm. And that cloud that you see there is an example of a cumulonimbus cloud. Really cool shot with the sun kind of illuminating one side of the cloud, but inside that bad boy, it is very turbulent. There's wind going every which direction, up and down, and that is what gives us fits sometimes.
It really does. The vertical motion. In fact, if you look at the cloud, it looks like a nuclear explosion, really, a mushroom cloud. But that's what's happening here. Now, not nuclear, of course, you know, but we're getting big rush, nuclear explosion. You have basically a big rush of heat that goes up and carries all that dust with it. Here you have a big rush of heat, but it's a little calmer, okay, but and not nearly as dangerous. But it does move that air up very quickly into the atmosphere.
So we'll call it an atmospheric explosion.
Yes, atmospheric explosion.
And we actually do have a little animation that kind of shows that here for thunderstorms. So what we did, we've kind of taken this picture, made it a little bigger, and you can see we've kind of superimposed some circles on there that are rotating.
Yeah, let's show it.
Let's take it up full, and you can see there what we were just kind of talking about. So again, the collision of warm and cold in the atmosphere, they're enemies. They don't like each other. They don't mix very well.
Yeah, they don't. The cold air is more dense than the warm air, so the cold air goes underneath while the warm air moves up top. And in the middle, that's where you get those circulations, and that's what Craig has drawn on there. And that's turbulent. This is why planes don't like to fly through thunderstorms, because not only is that turbulence help the thunderstorm sustain itself, but that's why you get big up and down motions that can really cause a lot of turbulence and make flying a real big problem.
And sometimes those turbulent winds, there's many different facets to a thunderstorm. But sometimes those turbulent winds can actually make it to the ground in the form of a downburst or the smaller microburst. So occasionally you can get winds that come rushing out of these thunderstorms, and it's like when you spill water in your sink. You pour the water in and the water splashes in the sink and it has to go out. That's kind of the same idea. In a downburst situation where that wind just comes rushing out of that thunderstorm, and when it hits the ground, it can't go into the ground, so it's got to go outward.
It spreads out, absolutely.
And that's where you could get some damaging straight line winds. Different from a tornado, which we will discuss. Let's see, we're at Wednesday now. Friday we'll be discussing that.
Okay,
so that's
so
kind
a couple
of a
days. Couple days. Wait for that.
Yeah, that's kind of a look. Or no, will we? I can't. We'll see. I have it all. I have it all in my head, and the days start blending together. So that's basically the explanation: the collision of warm and cool. And we want to talk about what you should do. This is probably the most important part of the lesson. Okay. We are going to be talking about tornadoes Friday. It just came.
Just got them.
Okay.
All right.
But first thing, you may have noticed on the last graphic that we had there on the bottom, I have a little quote that says, "When thunder roars, get indoors."
Get indoors.
So I want you to remember that, because if you're outside playing soccer or baseball or whatever you're doing outside, and all of a sudden you hear off in the distance, boom.
Yes, or a rumble.
Yeah.
A rumble of thunder.
You are close enough to be struck by lightning if you can hear the thunder.
Even if the sun is out.
Right.
Yeah.
Yeah. It's a phenomenon called blue lightning, I believe.
Something like
that. But that is a case where lightning could actually come out of a blue sky. It happens.
It does. I mean, most lightning, as you might guess, occurs in the center of the storm. But in the anvil, which is on this picture here, okay, the anvil right there at the top, okay, toward the right, that's what the anvil cloud there. Light, those are charged particles up there, and that part can actually be the long stroke that can go as much as 10 miles away from the storm itself. So we have what's called the 30-30 rule.
Okay.
And the first 30 is if you see lightning, and then you start counting 1001, 1002, 1003. If you hear thunder before you get to 30 seconds, it's time to seek shelter. Okay? And the last 30 stands for you can go outside 30 minutes after the last rumble of thunder. That's what we call the 30-30 rule. May sound a little extreme because, usually once the sun comes out, the storm's over. Yeah, let's go. Okay, but to be safe, you really should wait a good half hour before you hear the last rumble of thunder.
So when thunder roars, indoors. That's where you got to be. Because again, we don't want you to get struck by lightning. And we're going to talk a little bit about lightning. Someone actually sent us an email saying they wanted us to talk about lightning. We're going to do that today. If there's one thing as a meteorologist, and probably pretty universal amongst all meteorologists and non-meteorologists, there's one thing that scares me is lightning.
Okay.
That's one thing that does scare me. So let's talk about where you can go for safety in a thunderstorm. You are infinitely safe inside a building, okay? So if you can get inside a sturdy building during a thunderstorm, that's your best place to be. So indoors. That's why we say when thunder roars, get indoors.
Your house, school, apartment building, I mean, any like Craig said, enclosed building, not like a pavilion where it's just covered at the top and open at the bottom. You want to be inside a building. And once you're in there, statistics say you basically have cut your risk of getting struck by lightning by 96% just by going indoors, as long as you, A, stay out of the water, no baths, no showers, stay away from open windows. You want to watch a storm, keep the window closed, but just to be safe, don't put your nose against the window.
Yeah.
Okay, don't touch it. Watch it from a distance. And basically, no open doors, no open windows. I know it's hard because, especially if your house is stifling, it's hot, and your mom says, keep the door open. Let's get that nice, cool air coming in. We get it. If they insist on keeping the window and door open, despite your protests, you want to stay a good 10 to 15 feet away from that open source. Most bedrooms are maybe 10 to 15 feet wide, so basically, don't go in the room if they insist, or maybe you can at least crack it open. But it's best to keep the windows closed, all doors closed, and be safe.
Now, some people ask, is your car safe? If you can't get into a building, you're outside, is your car safe? The answer is yes, it is safe, but it's not for the reason that you might have heard. A lot of people say, well, the rubber tires will protect you. It's not 100% true, because the rubber of those tires would have to be something like a mile thick to stop a lightning bolt.
Right.
The reason you're safe inside your car is because of the steel. And how if lightning were to strike a vehicle, which is very unlikely, by the way, that lightning would travel around the outside of the
outside,
vehicle.
where the frame is, you know. So unless you have like metal seats, okay, you're not a baseball stadium, you know. But unless, you know, fortunately, most back in my day, there was a lot of metal in the car, and so it was a little more dangerous. Now we have vinyl and plastic and rubber and everything, canvas, so it's a lot safer. But as Craig said, it goes on the outside of the car. And keep in mind, there is metal in your tires. There's been metal in your tires since 1975 when they put steel belts in. So what it does, it goes around the frame. It'll attract the metal in, goes through the axle. It'll attract the metal in the rubber and very well melt it, melt that rubber. So you're going to pop the tire. But then it goes into the ground, and it's grounded. Okay, so but yes, there is metal in that rubber tire.
So car is a safe place. Building is better, but if you can't get to a building, car is a safe place, but not because of the tires. We just wanted to dispel that little misnomer there. All right, speaking of lightning, let's delve into the shocking stats of lightning. Like I said, this is if I'm outside and I hear thunder or I can see the light, I don't take any chances.
No, nor do I.
It's lightning is a serious and kind of mysterious thing that we study. We still don't know too much about it, mainly because it's so fast.
Right.
So quick.
Lightning quick.
Yeah, let's take a look at some of these shocking stats, as I've called them. So 5 times hotter than the surface of the sun, okay? Now, the sun's surface is 10,000 degrees Fahrenheit. Now, for those of you who are working on multiplication, listen up. So, if the surface of the sun is 10,000 degrees Fahrenheit, we need to go 5 times hotter than that. So, if those of you who are working on multiplication right now, this is your question. What is 10,000 times 5?
10, 20,
30. If you answered 50,000 degrees, you're right.
Good for you.
Good job. That is how hot lightning is. 50,000 degrees, and it happens in 1/10 of a second.
1/10 of 1 second.
Yeah.
Micro fast.
It's crazy.
It is really crazy. But that's what makes it dangerous and so unpredictable. Lightning is it's a static charge, not too different from when you walk across a carpet on a dry day and you touch metal, you touch something, you get a shock. That's what lightning is.
Kind of the same thing.
It's a static charge. A lot more voltage.
Yeah.
And a lot more dangerous, absolutely.
And some people, I'm just going to take a quick moment. I don't know what happened to our clock over there.
Yeah, the clock reset.
Okay. But we'll just take a quick moment to dispel some quick myths about lightning and some other facts as well. Last night was a perfect example. There is no such thing as heat lightning. It's not a thing. Doesn't exist. At night, when you see lightning, in the distance, that is a distant thunderstorm. So there's no such thing as heat lightning. If someone says, oh, did you see the heat lightning last night? They're technically not right. I mean, because there's no such thing as heat lightning. That's a distant thunderstorm, but the speed of light travels faster than the speed of sound. So you could see the lightning, but you're not going to hear the thunder because it's too far away, okay? So no such thing as heat lightning. When you see lightning at night, and it kind of has that kind of pinkish hue to it, that's just a distant thunderstorm. So yes, there has been a term floating around called heat lightning, but meteorologically, there is no such thing as heat lightning.
And the reason it is as you might expect, usually you see this kind of lightning at night when it's easier, and it's on hot, humid conditions. And you know, they associate the heat with that, but that's really the only reason that we have.
Yeah.
So.
And one other quick fact is we mentioned how lightning is 50,000 degrees Fahrenheit. And what you're hearing is, it's kind of oxymoronic, and I don't mean to confuse you, but you see the lightning and you hear the thunder. Well, what's happening is when a lightning bolt occurs, the air around that lightning bolt is instantly heated to 50,000 degrees in 1/10 of a second.
Right.
So what happens is that air around that lightning bolt expands and contracts really quick. And that's when you get that clap of thunder.
Exactly. And because sound is what we call a pressure wave. When it expands and then contracts, when it expands, it pushes the air next to it, like pressure. That pushes to the air next to it. And it keeps going. Now, we're social distancing here, but if I were to keep going, it would eventually go to your eardrum, which can sense that vibration. So that's why we have the thunder. That's why you hear it. Obviously, the closer the lightning, the stronger the sound, and the farther away you are, because as it keeps pushing, the energy is a little less each time you get the push.
All right, Tom, let's continue on with our list here. I'll let you take this one.
Okay, shocking stats here. The air, particles in the air rub together very fast to create the charge. Just like when you walk on a carpet and you're rubbing what we call electrons, you're charging your body. Well, raindrops and hailstones do the same thing. So they create positive and negative charges. Now, everything on Earth also has a charge. So if you have, what happens, the charges conglomerate in different parts of the cloud due to electrical physics, which we won't get into here.
Yeah. I don't even know that stuff.
So when that happens, now the air is an insulator, and it keeps the charges separate. But after a while, the charges get so strong, just like when you get shocked, that especially around metal, tall objects like trees, which have water, which does conduct electricity, if the charges are opposite, like if the tree is negative and there's a positive charge in the cloud, boom.
Got to release the energy.
And that's what you see as lightning.
Yeah, so as those charges separate, the energy needs to be released. And again, just to reiterate, if you can hear the thunder, you're close enough to be struck by lightning, because what lightning does is it looks for one of three things, like you just mentioned, Tom: metal, okay, or tall objects in open spaces, or water. So if you're out on Lake Erie or Conneaut Lake or Findlay Lake, any area lakes and waterways, and you hear thunder, you need to get off the water.
That's right. Lifeguard doesn't say stay in the water when there's lightning.
Yeah.
They say get out, and that's what you need to do.
And that's also why we mentioned, don't take any baths or showers during a thunderstorm.
If the lightning should strike the house, and again, the odds of that are very small, and even if it does, it could go through the wiring and through the plumbing and perhaps electrify the water. That's why we tell you not to take a shower. And you can wash your hands, you can go to the bathroom, okay, you can do that. But baths and showers, pools, stay out until 30 minutes after the storm is over.
Lightning's nothing to mess around with, for sure. I mean, it's pretty serious, and like I said, if there's one thing that really makes me nervous, it is lightning, because it's 50,000 degrees. It's deadly.
It is.
It's deadly.
It is.
So you got to take it seriously. So again, if you can hear thunder, the big part of the lesson, not only the multiplication tables that we did.
That's right. A little math.
But if you can hear thunder, you got to get inside. So remember, when thunder roars, get indoors and wait until 30 minutes after.
You got it.
All right?
Okay. It's that time.
It is
Okay.
that time. Let's ask again what inspires you, and we want to hear from you. So send us your weather questions, weather@WJET.TV. Now we're hoping that we can inspire you to be interested in meteorology, but whatever interests you, go explore that, learn as much as you can about it. And maybe someday you'll get paid to do it like we do, talking about weather. So if you have weather questions, that's the address to send them to.
Okay, thank you so much. That is our Weather Academy for today. On behalf of Craig Flint, thank you for your efforts once again. Thank you for watching, and we will do this again on Friday.
See ya.